Okay, so we want to talk a little bit about project crashing, and it goes without saying that there's going to come a time where the time estimate that you've come up with or are facing is insufficient to your needs, which is to say you need to shorten the project. That could be because early parts of the project you've fallen behind and you're trying to get back on schedule. It could be that when you did your time estimates, it's not meeting certain timings. And so what project crashing is about trying to expend resources, so it's going to cost us, in order to trade that for time, to try to find the most efficient way to shorten the duration of the project. And what we want to do is we want to look at a process or discipline on how we can examine our project and find the most efficient ways that we're able to crash the project or shorten the project by applying resources in the right spots. So we start off, and I know I've mentioned this several times, is when we come up with a time estimate, we're making an assumption with regards to, not just an assumption, but a decision with respect to the method that we're going to use and the resources we're going to consume in order to make that happen. And you know, it could be that there's assumptions that have to be validated on that, but at this point in time, we actually have a plan, we have a decision, we have a cost and resources estimated, and now we need to see or to re-examine those time estimates to see if there isn't a different method or a different amount of resources that couldn't be applied to the task in order to accelerate it or bring it forward, make it happen a little bit faster. So some of the normal assumptions that may have gone into the time estimate is how much labor was available, what technology was going to be used, whether it was going to be done with in-house labor or whether it was going to be subcontracted, whether it was going to be done usually, using normal shifts, labor shifts, or whether overtime was going to be approved. And so by reconsidering some of these assumptions, it may be that we can apply additional resources to certain tasks in order to accelerate how fast they're going to be completed. So the reality is that there's probably multiple possible solutions for each task based on different sets of assumptions. And so now we're going to, based on the need to accelerate our project, relook at some of these assumptions to see if we can't find alternatives that will help us meet our objectives. So what is project crashing then? It's basically changing the method or the resources in order to speed up or expedite the project through its activity. So looking at each individual activity and seeing if we can't find a different way. There are certain things that we have to obviously make sure, the resources have to be available to us in order to make that happen. There's no sense looking at options that aren't feasible, that can't be implemented. So we also should be conscientious of the fact that when we crash a project, all of the subsequent tasks that follow it also have to be affected or brought forward. And so they also have to be possible to do all of that. Otherwise, we're spending money to crash a particular activity without the impact that we need it to have. And so that impact is complex. All the resources that you've looked at, all those interdependent resources that you're sharing with other projects, all of those have to be able to shift in time in order to accommodate the crash project. Otherwise, it's not really worth looking at. So it probably goes without saying that crashing a project often introduces secondary or tertiary impacts and unanticipated problems that follow on in other tasks and everything else. And so, you're going to have to do your best to try to look forward and anticipate those problems and make sure that you're not introducing secondary issues that can't be mitigated. So the critical path method, crashing a project, time and costs, we know are interrelated. So if we spend money, we may be able to do a task faster, we may not. I think that's part of the assessment that has to go on. However, it's probably a truism that if you're going to make it happen faster, it's probably going to cost you money to do that. So if we change the schedule, we're going to change the budget. Those two are interwoven, but I think at this stage we know that we're trying to achieve something and we're willing to spend money or spend resources in order to achieve it. So what we need to do now is to look at our work breakdown structure or our CPM and look at the various activities within the work breakdown structure, and based on a reconsideration of the assumptions, come up with a second more expensive cost for a shorter duration activity where that's possible. And basically we're going to come up with a crash time based on a crash cost. And so something that is going to save us time or take us less time to do, but a different cost in resources in order to achieve it. So some of the things that we need to consider when crashing a project, first off, as previously mentioned, we have to make sure that it is permissible, that it's achievable, that we can actually get it done. And be conscientious of what other problems we're introducing. And our fundamental principles then that we're going to focus on is we're going to look primarily at the critical path. Keep in mind that the critical path is where you have no slack. And so if you can save a week on the critical path, you're saving a week on the project. And so that is where the greatest efficiency lies. If you don't shorten the critical path, then of course you haven't saved yourself any time. So we're going to focus on the critical path, and we're going to try to do it with the least expensive options. So by looking at each of our activities and figuring out what its normal cost, normal time is, its crash cost, crash time, we can see how much time we're saving and how much it's costing us to save that time. So we're going to do that in a series of steps. So the first thing we need to do is to compute the crash cost per time period. So we're in our work breakdown structure. We're making a different set of decisions, and then we're going to come up with a different cost and a different time estimate and figure out what we're saving. And normally we would express that as a crash cost per time period so that it can be compared across activities. And then using the current activity times, we're going to find the critical path and identify those critical activities so that we know which activities we're playing with in order to try to save time. And we're going to select from those activities the ones that can be crashed and has the smallest cost, crash cost per time period. Now, one of the things to consider is that if you have more than one critical path where they're running in parallel, you have to shorten both paths in order to shorten the project time. So that also has to be considered in selecting which activities you're going to try to crash. And so then we'll update all of our activities and redo our CPM. So now we may have changed the critical path and consider if we've achieved our goals. And if we haven't achieved our goals, we'll just go through that process and continue to go through that process until we achieve what it is that we set out to do. So if we look at a quick little example, so this is our Milwaukee Hospital example that we've been nursing through the last little while with all of its activities. Now, in this case, what we've done is we've shown not just the normal time, but we've come up with a crash time. And of course we have our normal estimate, and now we have a crash estimate, so it's going to cost us more to achieve that. And then that's been reduced down into a crash cost per time period, or per week in this case. And so we can just represent that here. So we have normal cost, normal time. This is for activity B, taking $30,000 for 3 weeks. And then its crash cost is $34,000 for 1 week. And so the slope of this line is that crash cost per week. And it can be calculated here as $2,000 per week. Now, one caution. It may be implied based on doing that calculation that we're saying it's linear, that, okay, maybe we don't need 2 weeks, we only need 1 week. So we'll go from 3 weeks to 2 weeks and only spend $2,000 instead of the 4. And that may not be true. To be fair, I think you have to, normally we annotate the tasks, which ones are kind of a linear extrapolation and can be crashed in increments other than the one that's described. But for many of them, they actually just represent discrete options. We can do it this way or we can do it that way. And so you have to recognize those limitations in making your choices. So in this case, if I were to look down all of the critical path activities, if it was that I was trying to save a week, the best or most efficient place to do that on the critical path would be activity A. You note that activity F is cheaper in its crash cost per week, but it's not on the critical path, so it's not going to have the impact that we're looking for. So having done that, if we assume that we crashed activity A, what we see is that we've actually introduced a second critical path into our activity. So if that 1 week that we were saving wasn't enough to meet our goals, now as we consider our second iteration of crashing the project, we actually have to consider the parallel critical paths and make sure that we're either at a nexus that is shared between those critical paths and saving space. So in this case, that would be activity G, or we have to crash both paths. So let's look back at what we're at now. So we've updated it for the crash that we executed. We now have 2 critical paths, and so if we're trying to save additional time, we're either going to have to crash both D and E. That would be, to do both would be $1,500 per week, or crash activity G, because it is shared between the 2 common critical paths, again at the same price. And so you have a choice, and you have to figure out which one makes the most sense for your particular project. So there's another tool which is really useful, and I'm going to use this example to develop it. So this is the Gantt chart for a small little project that we have laid out. And again, in the table, we're showing normal times, crash times, and we end up with what they call a slope cost, or that's the cost per time period. And we're going to come up with a whole series of options. So in its normal original plan, it called for 8 days at $120 cost. And if we were to crash activity A, which is the up here at $80, we can get down to 7 days at $160. Now C is cheaper, but it's not a critical activity, and so it doesn't achieve what we're looking for. So our first option is to crash activity A, and we reduce the cost or reduce the time period for the project to 7 days, and now the project is going to cost $160. And then if we want to continue and to shorten up the project at ever increasing costs, we can come up with a series of new Gantt charts or new plans, the Gantt chart really just representing those new plans, which shorten the project and continue to shorten the project. So we've already talked about the normal, which is up in the top left, 8 days at $120. If we crash A, we go to 7 days at $160, and we've compressed the project there. If we crash both A and B, we can get it down to 6 days, but now we're up to a cost of $220. And then to go beyond that, we're going to have to do not just A and B. We're not going to do A and B. We're going to do A, D, and E, which gets us down to 5 days at $260. And if we crash A, B, D, and E, we get down to 4 days and $350. And so the best way to represent that is on our cost crash curve, which is this time cost relationship for crashing the project. And we'll just draw it out here. And these represent all of those options that we were looking at on the previous slide. And they're saying, okay, this is the project duration based on the estimated cost. And they're just labeled with which activities you're choosing to do at the higher cost or the crash cost. So, you need to take this information and you need to compare it to the other factors that may want you to crash the project or not. And certainly, if you're having a negotiation with your client or whatever who's pressing you for an early delivery, having all of this information available to you so you can identify what that cost is going to be to deliver it at an earlier stage would be very useful. So the other thing we want to talk a little bit about is fast tracking. And it's another way to expedite a project. They talk about it with respect to construction projects, but it can be used in other projects. And they talk about it as a methodology to overlapping a design and build phase. And of course, within that industry, we talk about that design build methodology. And really, I think of it more as a methodology. It does enhance risks when you're stepping off on a not fully defined project. You have to make some assumptions as to what's going to be delivered in the second half. So even technical design decisions on the early start, where you're building foundations before the structure is built. As an example, you're making assumptions as to how heavy the structure is going to be, and perhaps making some, or maybe padding your decisions so it might cost you slightly more money because you're giving yourself some latitude for decisions not yet made. But if the cost savings associated with the accelerated time make up for that, then that all works out. I actually think of fast tracking a little bit more fundamentally in that you probably establish a series of decisions around what is normal. And normally we don't want to work a whole lot of overtime. That costs money. We don't normally want to hire additional labor, and that type of thing. But if you want to fast track and you say, okay, different set of decisions, and you move to a different column, says, okay, overtime is authorized within X number of hours, we can do this, we can do that. And so you can just accelerate the pace of output by changing the table of norms that you're going to apply to how you're going to execute your various project activities. And so that's typically the way I think of fast tracking, is to make more expensive choices because the time constraints of the project benefit it, but we're going to just apply that across the board, or through a subtask or whatever. They do talk about a lot of reluctance to go design build because it leads to late project change orders and stuff like that, and that hasn't really borne itself out in practice. Personally, I'm a big fan of design build, but that's part of my bias because I come from projects that were highly time sensitive. And to be fair, I was also the technical authority for the design at the same time as being the project manager. And so I was managing my own risks and not choices by other people. So it certainly works really well for construction. I think there's much to be said about it. So there is a video on the LMS which deals with the Big Dig and some of the innovations that they did around the construction of the Big Dig, particularly the bridge replacement program on the interstate. I encourage you to look at those and not necessarily look at them from the perspective of fast tracking, but how innovation and methodology and breaking down some of the barriers of how we've always done things can lead to incredible savings in time and costs and everything else. So with that brings us to an end for scheduling and risk. There's a lot in there. As we mentioned earlier, they are somewhat tactical skills, but they have incredible strategic impact. They're simple in their methodologies, but complicated in their implementation. I think they're a lot of fun, and I enjoy the puzzle piece of trying to get them all to fit. So with that, we'll let it go, and we'll see you as we start to execute our project and look at monitoring and controlling and some of the other aspects associated with that.